So now we will continue with our chapter of elements, mixtures and compound for standard 8th chemistry. We had already done the elements and compounds part in the previous videos of this chapter. Now today we will see the part of the mixtures of this particular chapter. So first of all, we come to know that elements and mixtures with the pure substances. So and when we differentiate the metals into different types, then we have one which was pure and other was impure. In the pure substances were the elements and the compounds, as they were made up of only one kind of molecules. Okay, so because they were made up of one kind of elements and molecules, that's why they were atoms and molecules, that's why they were pure substances, and they were always in a fixed ratio. So that was the main property of the element and compound. Now in case of mixture, so mixture is made up of two or more substances, which could be an element or compounds or both. Okay, it could be two elements or three elements combining together to form one mixture, or it could be one element and one compound forming a mixture, or maybe two or three compounds combining together to form a mixture. So the mixture could be a combination, or it is the substances when it is mixed up mechanically. Now the main thing over here is that the mixing up of these elements or compounds is only mechanically. They are not chemically combined. There is no chemical bond between the elements or the compounds which are being forming the mixture. So that's why we say that it is two or more substances, elements or compounds or both, mechanically mixed together in any proportion. So it is not necessary that it should be in the ratio 2:1 or 5:2 or 3:4. No, it could be in any proportion. Any proportion, if it is there, it will be called a mixture. So a mixture retains the properties of its constituent elements or compounds. So the main thing is that it differentiates, a mixture is differentiated from a compound, is that in case of a mixture, the individual properties of each and every constituents of the mixture are retained, whereas in case of a compound they are lost. I give an example that in case of water, hydrogen and oxygen both have got properties which will help support burning or support combustion, or it is required for combustion, whereas water has got a property completely different, that is a fire extinguisher. So you can see that hydrogen and oxygen, then they form into water, they do not retain any of their properties. So in a compound, the properties are not retained, but when we take a mixture, the mixture will retain its properties. So each and every element present in that mixture will retain its property. Like for example, let's take the best example is the air. Air is a mixture. Okay, air is a mixture, that's why it has got nitrogen in it, it has got oxygen in it, there's a carbon dioxide in it, and that oxygen is having its own identity. It is retaining the properties of being an oxygen in the air. It has not lost its property of being oxygen. So oxygen is required. So when we burn something, oxygen is there. So yes, that oxygen is working out over there. So that is how we can understand chemically. Let me give you a very it's a vague example because you cannot call it as like a mixture as such in the chemistry form or point of view. But the best example could be bhel. Okay, bhel puri khate hain, bhel. That bhel is the best example to understand the mixture. I'm not saying that bhel is a mixture. Of course, it's a mixture, but we cannot consider it as in terms of chemistry, we cannot consider it to be as a mixture. But if we consider the example of bhel, we come to know that whenever you eat bhel at any place, you will find the taste slightly different. If you eat your bhel at home, then it will have a different taste. Eat roadside, it will be different. In some hotel, it will be different. In some kind of a party or some kind of a marriage ceremony, if by chance some bhel is there, then it will be different. Everywhere you will have different taste. Each and every shop of bhel will have different kind of bhel available to him or with him, because and you will see that in each and every case, when you are eating that bhel, you can easily identify the taste of the constituents of bhel. You are eating the bale and you find, अरे हाँ ये तो सिंगदाना है ऐसा लग रहा है. Okay, अरे नहीं नहीं ये जो पता है, I think there is some aloo inside, or this is onion inside, or garlic inside, right? Or the save what is being put is slightly hard, it is not so soft. Some or the other thing will come in your mind, that every time you will be able to identify that particular thing what you are eating from that bale. So that means that whatever has been put inside the bale, वो इवन आज के ये भी डालते हैं that कच्चा केरी, okay, so the raw mango what you put in, that will also give that particular taste. So all that things what is being put in the bale gives you a separate taste. So that means each and every constituent of the bale retains its property. Okay, you can see it's very much connected to mixture. That's why I'm telling you a best example is bale, because each and every ingredient what we put into the bale is being is giving you a particular taste, a particular kind of a flavor to it, and that is why we say that the mixtures retain, the components of the mixtures or the constituents of the mixture retain their properties. Right, so this is way that mixture are the one in which the constituents of the mixture retain their properties of the elements and the compounds. So that's the example we given over here is Cu and Zn. If you take Cu, some quantity of powdered Cu and some quantity of powdered zinc, and you mix them together and then you heat it and you get a particular mixture which is called as brass. So the brass is the one. Now you will always find that brass has got the properties of both copper as well as zinc, and that's why they are added together, so that some of the we can say enhancing the properties of copper. See, copper as such will be slightly softer, तो उसको हम लोग को थोड़ा shiny feeling चाहिए, या वो copper may get corroded and become black in color, so you don't want that thing to happen. So what you are doing, you are adding some zinc to it, which is giving it a protective layer also. At the same time it is giving you that luster. So brass is going to be of that kind. Similarly, NaCl and water, salt water. You can get salt water in any form. Like salt water of the sea will be very very salty. Okay, it is also salt and water. You take it home, you take some water and put just 1 teaspoon of salt. It will be different taste. 2 teaspoons will give you some different taste. 3 teaspoons will give you different taste. So automatically you will find that the mixture, whether it is 1 teaspoon, 2 teaspoon or 10 teaspoon, the glass of water will be called salt water only. So that's a mixture. Then we have got which is called as gunpowder, which is the combination of sulfur, carbon and potassium nitrate. So potassium nitrate, sulfur and carbon, when they combine together, we get what we call it as gunpowder. So these are certain examples of mixture. Now when we talk about the mixtures will be basically of two kinds. One will be homogeneous and another will be heterogeneous. Homogeneous means that the mixture is such that it has been made up of or it has been mixed so well that each and everything is properly mixed together. Okay, just a minute. Okay, sorry. So yeah, a homogeneous mixture and heterogeneous mixture. So we can see that the mixture is divided into two parts. One is homogeneous and other is heterogeneous. Homogeneous means the constituents of the mixture are thoroughly mixed with each other. They are completely mixed with each other. Like for example, the salt water. When you drink the salt water and if you have stirred it properly, it becomes a homogeneous mixture that you taste the first sip or the last sip, it will always give you the same taste throughout the glass if you take that much. So you can see that the salt water is a homogeneous mixture wherein everything is combined together in a well mixed form, that each and every small bit of it is also having the same properties. So uniformly mixed is homogeneous mixture. So constituents of the mixture, when they are uniformly mixed, we call it as a homogeneous mixture. The properties of composition same throughout the mixture. So with throughout the mixture, it will be the same kind of the properties. So that's why it is a homogeneous mixture. The examples would be when two solids like copper and zinc are mixed together to form brass. So of course you will always have all copper and brass, zinc, all of them completely mixed thoroughly. So it will not happen that this part has got more copper and this part has more zinc. No, it will be completely the same throughout. Similarly, salt water will be thoroughly mixed. So even if you don't stir it properly, that also the quantity will be almost absolutely homogeneous. Two liquids like the alcohol and water. So if you take alcohol and water and you mix them together, then also it will be thoroughly mixed. So it will be completely the same way. And finally, other gases like two gases will be air. So air is also homogeneous mixture because it is not going to happen that any side पे चले यहाँ पे मेरे को oxygen नहीं मिल रहा है. Okay, it will never happen that way. कि नहीं ये पाइप पे मत खड़ा रहे वहाँ पे से ना वो कार्बन डाइऑक्साइड ज़्यादा आ रहा है. No, it will be homogeneous. So in a particular location, the air will be thoroughly mixed completely. So that's why it is a homogeneous mixture. Similarly, heterogeneous mixture, constituents not uniformly mixed. So if the constituents are not uniformly mixed, then it is a heterogeneous mixture. So properties of composition may vary throughout the mixture. अगर फिर से एग्जाम्पल ये तो भेल का तो हो सकता है या हेट्रोजीनियस बोल सकते हैं टू सर्टन एक्सटेंट. यस, भेल पूरी इज एन हेट्रोजीनियस वन because the taste what you are going to eat means of course the flavor of the chutneys will be homogeneously mixed, but the taste of the small things which is going to be coming up in each and every bite of yours, like एक बाइट में आलू आया तो दूसरे बाइट में कच्ची कैरी आई तो तीसरे में टोमेटो आया. So every time you will be having some or the other taste or some singdana may come over there. So everything which is coming at a different kind of it. So of course the property is not the same throughout the mixture in case of a heterogeneous mixture. The example will be two solids like iron and sulfur. So if you take iron and sulfur, you cannot mix them thoroughly properly. There will always be that iron clubbing up together on one side and sulfur clubbing up to one side. So there will always be something like a lumping of iron and sulfur in between. Solid and liquid like sand and water. If you take some water and put some sand inside and you even stir it, what will happen? After a few minutes it will settle down and the whole water will slightly become dusty. It will not be transparent though, but it will be dusty. You can see that the lower portion has got more concentration of sand and the upper part will be having less concentration of sand. So accordingly you will find that the whole glass of water will not have a uniform distribution of the sand in it. So that's why it is a heterogeneous mixture. Two liquids like oil and water. You always know that oil and water, they are going to be separated. So अगर मैंने एक oil है, oil के ऊपर अगर मैंने पानी डाला, तो you will always find that the oil will float on the water and it will form a kind of a cluster. Or you can see that अगर पूरा का पूरा layer है, तो oil will be on top of this much layer. So if I have got a test tube, if the test tube is there, this is a test tube and it's filled with water and I put some oil into it, the oil will be coming as a layer on top of it. So this is going to be, the mixture will not be mixed thoroughly at all. So this are called as immiscible liquids. So when the liquids do not mix with each other properly, they are called immiscible liquids. So these are examples of heterogeneous mixture. In gases, we do not have any kind of a heterogeneous mixture because gases normally diffuse very easily. They get mixed to each other very easily, and that's why they always give you a maximum amount of homogeneous kind of mixtures. So now let's just discuss about the differentiation between a compound and a mixture. So what they have done is that they have given you an example of two substances. So one substance over here, so we have over here the compound and you have got a mixture. So they have taken iron, that is Fe, and they have got sulfur over here, and here also they have taken iron and sulfur over here. So this is iron, Fe is iron, and this is sulfur. So this is also iron and sulfur. Now what they've done is, this particular thing they heated it up. So यहाँ पे उसको heat किया, और उसके बाद what you get is iron sulfide. Where here they just mixed it together. So now let's see what exactly is going to happen now. So first thing is, composition wise, The components present are in fixed ratio. Fe plus S will give you FeS. So the quantity of Fe and the quantity of S is equal, and it will always be forming into iron sulfide, which will have the ratio of Fe and Se as 1:1. Whereas here you can have more iron, more sulfur, कुछ भी कर लो, mix कर दो, कोई फर्क नहीं पड़ता. Okay, so this will be like mixing up. So components present in varying proportions in case of mixtures. Nature wise, this will be homogeneous, because you will see that it will be a completely a different lump of thing that will be slightly blackish in color. So this will be iron sulfide will be given you a particular homogeneous kind of a mixture, whereas this one, it will be such that it will be homogeneous or heterogeneous depending upon what kind of mixing is done. अगर proper mixing किया रहेगा and it is very very powdery, both the things are very powdery, then yes, it is possible to have a homogeneous mixture of iron and sulfur. But normally it will be a heterogeneous mixture, because sulfur will slightly form lumps, and even the iron filings may not be so spreading easily. So they will become a area will be there which is stuck to each other. So anyway, so the nature will be homogeneous or heterogeneous in case of mixtures. Properties wise, components do not retain their original properties. So now if I take a magnet and I place it inside this iron sulfide, you will find that the magnet is not going to attract anything at all, because iron sulfide is going to have the property completely different from iron as well as sulfur, and accordingly this particular thing is completely new substance which does not have the property of iron or sulfur. So they do not retain the original properties. Whereas over here, if I take a magnet and place it inside, all the iron filings are going to stick to that magnet, and sulfur can be easily separated out. So you see that the properties of the components are retained in case of mixtures, whereas in case of compounds they are not retained. So components retain their original properties in case of mixtures. Separation wise, the components of a compound can be separated only chemically. So it can only be separated by chemical means. You cannot separate this by any kind of physical means. You cannot do, जैसे मैंने बताया, I cannot take a magnet and take out iron. It's not possible. Whereas in this case, it can be easily be separated by physical means. So that's the reason that mixtures, you can easily separate the mixtures by just physical means. So that's what they are given you in the example for the figure also, that the iron sulfide, you are not going to get attracted to the magnet, nor does it give a hydrogen gas when dilute hydrochloric. If you give see, normally what happens is that if I take Fe, okay, if I take iron and I put it in a test tube and put acid inside, then that acid, when I put the acid, I'm going to get hydrogen gas. So there is one particular kind of I would say chemical reaction in which that metals, when they react with acid, they give out hydrogen gas. So that's why we see that when I take in a test tube this particular thing, iron sulfide, when I take a test tube and put some acid in it, it is not going to give me hydrogen gas. So that means it has not got any property of iron balanced with it. Whereas in this case, when I take a magnet, yes, iron will get attracted to the magnet. That's the first thing. Secondly, even if I take it in a test tube, then I'll find that hydrogen gas is going to be given out by the acid as soon as I'm pouring the acid into the test tube containing iron. So this is how you see that the compounds and mixtures are compared to each other. So that was a comparative study. Now we see something very, very, very important in this chapter, and that is the different types of mixtures and the separation method. See, the most important thing is the separation method. Of course, different types is there, but mainly it is how do you separate those mixtures from each other. How you can separate the components of the mixtures is the main part which is there in this particular chapter, part of the chapter. So we have the first thing as the different kinds of mixtures. So we will not say much about the types. It is just a simple thing that if the mixture is of two solids, so it could be this way, that it could be a solid with a solid mixture, two solids mix with each other to give you a solid to solid mixture. The another thing could be a solid with a liquid. Okay, there could be a solid combining with a liquid. That is another option which is going to be possible. The third thing could be see, normally solid and gas will never be there. Solid will never have a mixing up with the gas, so that won't be there. But yeah, liquid will be with liquid. So next one will be liquid to liquid, and then it will be gas to liquid or liquid to gas, liquid with gas, and finally will be gas to gas. Okay, so the and of course, yes, there could be something which will be called it as complex. So the mixtures could be of, I would say, 6 different kinds. So the 6 different kinds of mixture could be, the first one could be solid to solid mixture. Now solid to solid mixture means 2 elements are there, and these 2 elements are combined together, 2 metals combined together to form a mixture. So now here the main particular thing about the kind of the solids will be, we'll do one thing, I'll just list them down right now, but then when we are learning the separation method, at that time we'll come in detail about that particular part. So the first thing is just that in case out of the 2 solids, if one of the solid is a sublimable substance. What is a sublimable substance? Do you remember that? Yeah, that's right. This is from solid to gas directly. So when you heat it, it doesn't go to the liquid state and directly goes to a gaseous state. Then it is a sublimable substance. So if it is such that the solid to solid is first one is sublimable. So it is sublimation is the kind of thing. So if one of the substance which is there in the mixture is a sublimate or it can sublime, then we can say that this is a sublimable kind of a mixture. The second one would be magnetic separation, magnetic, so it is magnetic in nature. So if one of the element which is there in that particular mixture is magnetic in nature, that means it is getting attracted by the magnetic by a magnet, then it is called as a magnetic kind of a mixture, and there we will be using the method called magnetic separation. The third one will be when one of the element of the mixture is going to be dissolving type, that is soluble kind, and the other is insoluble. So that is, we call these kind of mixtures to be separated by solvent extraction. That means you are going to put it into you're going to pour some kind of a mixture in it, or you pour some kind of a solvent in it, in which one of the thing is going to get dissolved and other is not going to get dissolved, and accordingly you can get the separation of the 2 solids. So that is when you are going to use this way. And finally is fractional crystallization. That is going to be done in different form, which we'll take it in a proper manner. So it is fractional crystallization. So whenever you will have an additional amount of, see, when 2 substances are going to be dissolved in water, one of them will be more soluble than the other. So when these 2 are of different solubility, you can separate one of them by making it into a concentrated or by a saturated solution. We'll get in detail of this in the later part of the chapter, but yeah, so it is based on the solubility of the substance, means how much is one particular element soluble than the element or substance is soluble than the other. So depending upon the difference in the solubility, there will be the way of by which we can separate those 2 elements or substances from a mixture. So we can see the solid to solid mixtures can be separated by 4 methods. Sublimation, when one of them is sublimable. Magnetic separation, when one of the substance is magnetic in nature. Solvent extraction, when one is soluble type and the other is insoluble type. And the fourth one is fractional crystallization, when there is a difference in solubility of 2 substances. So we'll just read that time out. Sublimation is sublimable solid plus non-sublimable solid, that is NH4Cl and NaCl. So you can remember this thing, that ammonium chloride, NH4Cl, ammonium chloride, is a sublimable substance. Okay, and NaCl, that is common salt, that is sodium chloride, is a non-sublimable substance. So if I take some amount of ammonium chloride and I take them some NaCl, that is the sodium chloride, and mix them together, both are white in color, so I'll not get to know that which is the thing, so I cannot separate them so easily. So what I will do is I'll just heat it, the sublimable substance start evaporating and give me gaseous product of that particular ammonium chloride. So separation based on sublimable solid, sublimes on heating, leaving behind the other NH4Cl, sublimes on heating directly it changes into vapors. Magnetic separation, magnetic solid is iron and non-magnetic is sulfur. So we know that iron is going to get attracted by the magnet, the sulfur will not, hence it is separated. So magnetic solids attracted by magnet leaves behind other. So Fe, magnetic in nature, attracted by magnet. Solvent extraction, soluble solid is sulfur and insoluble solid is charcoal, carbon. So when you take sulfur and carbon and you mix them together, if I want to separate it, it's a very simple thing. I'll just add some kind of a solvent in it. So when I put that solvent inside, soluble solid jo hai, that is sulfur, will get dissolved in it, whereas carbon will not dissolve, and hence when I filter it out, the carbon gets separated out from the mixture of sulfur. So soluble solid dissolved in the solvent, leaving behind other. The solid S dissolves in the sulfur dissolves in solvent, recovered on evaporation. Fractional crystallization, soluble solid, that is potassium nitrate, soluble solid potassium chlorate. So both these are going to be soluble, but you will find the different solubility in the solids in particular solvent. So that's why potassium nitrate is more soluble than potassium chlorate. So accordingly, potassium nitrate is going can be easily extracted. So more soluble in water. So potassium chlorate can easily be extracted. The next is solid liquid mixture. So we have the next one is the solid liquid mixture. So we'll start over here. Sorry. So that is, I'll place it here. The first is filtration. So we very well know. One sec. The first one is filtration. So one is insoluble in the liquid. So if it is insoluble in liquid, I can just filter it out. So that is first one is filtration. The second one is sedimentation. So if it is something like sand, which when you keep it, it is going to settle down by itself. The dust particles will be settle down itself in water. So that is nothing but sedimentation. The third one is evaporation. You put it in a dish, let the water evaporate, and the salt is going to remain inside. So that is evaporation. So the liquid part, so you can see in the solid liquid mixture, the liquid part is getting evaporated and the solid is retained in the dish. So that is why it is called as evaporation. And the last one is distillation, that is fractional distillation. So it is just distillation over here, that in the distillation part, you are going to get the water from the salt water. So distillation process in which you are going to heat the water is going to form into gas, water vapor, that is going to condense, and the condensed water vapor is collected in the form of water. So these are the forms of solid liquid mixtures which can be separated by filtration, sedimentation, evaporation and distillation. In case of liquid, there are two things. One is if the liquid is sublimable, so if they are immiscible. So if it is immiscible, if they are not mixing up with each other, we can have a separating funnel. So separating funnel is used for such a condition when it is immiscible. And the second one is fractional distillation. So that is, fractional distillation is the one which is going to tell you about the difference in the melting point of that particular, or boiling point, not melting point, boiling point to form into gases. So difference in the boiling point of the liquids. So depending upon the difference in the boiling point, I can separate the liquid mixtures. In case of the liquid gas mixtures, they can be separated based on the solubility. So this can be based on just the solubility, you are just heating it to remove that thing. And gas could be separated based on the porous partition, that which is the heavier one and which is the lighter one, or which is soluble in a solvent and which is not soluble in solvent. So that will be based on gas. And for complex things, we have got chromatography and centrifugation as the two methods of separation. So these were in general the different forms of mixtures and their separation methods. So now in the next video, I will come to the different separation methods in detail. So that will be the next video.